Hello everyone, this is BronyCalc and welcome back to the 2014 ARML Individual Challenge. This episode, Problems 5 and 6, explained in 10 minutes or less. Ready? Go. Okay, so, Problem 5. We have a sequence of quote-unquote words where the first word is X, very fancy word right there. Next word is O, and then after that, we take the term 1 before, and we follow it with the reverse of the term 2 before. So for this one, we have O followed by the reverse of X is X, so OX. Then we have OX followed by the reverse of O is OX, OXO. OXO followed by the reverse of OX is XO, so OX, OXO. Next one is OX, OXO, OXO. And it continues like this, and we want to know how many of the first 1,000, are palindromes. So looking right off the bat, first one's a palindrome, second one's a palindrome, third is not. Fourth is a palindrome, fifth is a palindrome, sixth is not. So you might be noticing a pattern. Anyways, if we were to keep testing this, we could see the pattern continues, but the best way to work with this pattern is to prove it. So, here we have a palindrome followed by a different palindrome, which means flipping them isn't going to work, which is why this is not a palindrome. So we know why when we have two palindromes, the next one's not going to be a palindrome. Just because they're different lengths, so we would require the middle few terms to be the same, which is never going to happen unless these are the same, and that just can't happen. It's always going to end with some XO or OX. But then, why are the next two palindromes? Well, we see that this is a palindrome, and the palindrome shows up here, so we're just putting that in the back, and then we have this term in the middle, so when we flip it, that gives us a palindrome. And then if we do that again, we have this whole thing, so we have this plus the palindrome plus this in reverse. So if we flip that, then we have the reverse, which is just the first, and then the palindrome, and then the original reversed, which is going to be the same exact thing. So, in my very, very bad explanation by words, we can see that we have palindrome, palindrome, not palindrome repeating through all of them. So we have 2/3 of the first 999, that's the first multiple of 3 is 666. Oh, whoops, Satan. Plus 1, 667, we're safe. Okay, so that's done, but that took a little bit, so we're going to move on to the next one real quick. So we have a number n such that 214 times n and 2014 times n have the same number of factors. So 214 is 2 times 107 times n. This is 2 times 1007, which is some two primes. I don't remember exactly which ones they are. I think this one is 19, if I had to guess. Anyways, it's not all that important. So we have two primes that are not this one. So we see the 2's here. They have the same factor of 2, which means that's going to give the same multiplier when you compute the number of factors. So we don't have to worry about that. So we're looking for one. So if we really want to do this, we want to focus only on 107 p and q. So n is going to be p to the a, q to the b, 107 to the c. So we're looking for a plus 2. This is the number of factors here, by the way, because this is going to be the 2's we can ignore, and then it's going to be a plus 2, b plus 2, c plus 1. Number of factors here, ignoring the 2, is going to have to be equal to a plus 1, b plus 1, c plus 2. That one right there. And we want these to be as small as possible. So I see a little bit of symmetry between A and B. I guess it does matter what P and Q are, now that I think about it. Oh well. So, just looking at this, as we come up to our halfway mark, might as well calculate it. So we have 19, that I remember, so 1007 divided by 19. So this is 95 plus 5, so that's 53. This is going to be a nightmare to calculate. That's okay. C here. So let's try to make these as small as possible. Can we have C be 0? So can we have this be double that? Because that would be really nice. So we're asking, can we have AB plus 2A plus 2B plus 4 be equal to 2AB plus 2A plus 2B plus 2? Or AB is equal to 2. Well, that requires 2 and 1. So 19 squared times 53. Let's try calculating that out. 19 squared times 53. By the way, all these exponents are really small, so this is probably going to be our answer. 19 squared is 361. 361 times 53, well, that's 1083. 36 times 3 is 108. That's always nice to know. And then put the 0 there. We have 5 and we have 180, so that's 19133, which is indeed our answer, which means we are done. So we just used a little bit of wishful thinking there, brought out the science favorite factoring trick, and everything worked out hunky-dory. So I hope you enjoyed this video. If you have any questions, leave them in the comments, and I'll try to explain as best I can. Otherwise, if you like this video and the other ones, please subscribe. Oh yeah, check out the other ones too. Anyways, I will see you all later. Peace.